Welcome to the emergency equipment lesson in the PMDG 737 Next Generation groundwork from Angle of Attack. This lesson will cover some of the emergency equipment available to the crew and passengers on the aircraft. We should add the disclaimer here that we do go a little outside the realm of flight simulation in this lesson. The content we teach here should never be used in place of the safety briefing you receive before a real flight. No two aircraft are necessarily configured the same, so do not take this information as gospel. It is purely for your own interest and nothing more. This lesson will cover the following topics: the flight crew oxygen system, passenger oxygen system, emergency lighting system, and egress from the aircraft during an evacuation. So again, in a real aircraft, consider your situation, listen to the cabin crew, and respect that safety briefing. Oxygen systems are installed in the aircraft for the flight crew, cabin crew, and the passengers. Flight crew oxygen is stored pressurized in an oxygen cylinder, and oxygen for the passengers and cabin crew is chemically generated. At typical cruise altitudes, there is insufficient oxygen per unit volume of air to sustain human life. The aircraft is therefore pressurized to create a habitable environment. In the event of cabin depressurization, supplemental oxygen is required to sustain consciousness during an emergency descent. Flight crew oxygen may also be used in the event of smoke or fumes in the cabin, as the flight crew oxygen masks may be sealed completely, preventing cabin air from entering the system. The passenger oxygen masks combine oxygen with cabin air, however, so will be of little use in the event of smoke or fumes in the cabin. Controls and indications for the oxygen systems are located on the masks beside each crew station and on the aft overhead panel. The flight crew oxygen system consists of quick donning diluter demand masks and pressure regulators located at each crew member station and other system components. There are 3 masks on the flight deck, one for each pilot and one for the observer station. These masks are fed oxygen by a single oxygen cylinder that is located in the aft electronic equipment compartment. An access panel in the forward cargo compartment permits maintenance access to the oxygen cylinder. There is a pressure indicator on the aft overhead panel, and this shows the pressure in the crew oxygen cylinder. The masks are located to the left and right of the captain and first officer stations respectively. They are within easy reach for quick donning in the event that they are needed, and they're designed to be donned and for communications to be established within 15 seconds. The mask is removed from its stowage box by gripping the red clips and pulling. Squeezing these clips provides an oxygen flow to the mask harness, inflating it and enabling it to be placed over the head. When the clips are released, oxygen flow to the harness is stopped, and the remaining oxygen in the harness is vented. This tightens the harness over the back of the head, holding the mask to your face. The mask regulator can provide either pure oxygen or oxygen mixed with cabin air. With the normal 100% selector in the normal position, the mask system will provide a mix of cabin air and oxygen. When the switch is pushed in, the system will provide 100% pure oxygen. And this mode would be used in the event that fumes are present, as it provides pure oxygen and thus would not permit cabin air to enter the system. Oxygen may also be supplied under a positive pressure flow. This is achieved by rotating the emergency test selector clockwise. This provides 100% oxygen under positive pressure and can be used to clear the mask of smoke or fumes, or when at very high altitude where oxygen under pressure is required. The normal regulator mode is the usual mode when no fumes are present, as diluting the oxygen with cabin air allows the oxygen supply to last longer. The mask should be stowed with the normal 100% selector in the 100% position, however, to ensure that 100% oxygen is available immediately after quick donning. It's worth noting that when you're wearing the mask, you cannot actually see these controls, so it's important to be able to actuate them by feel alone. The oxygen masks should be checked during initial pre-flight to confirm integrity of the system. The mask does not need to be removed from its stowage box to perform the pre-flight check. To test the system during pre-flight, push the reset test switch and observe that the yellow oxygen flow indicator in the upper left of the unit shows. To check positive pressure supply to the regulator, push and hold the reset test switch while pushing the emergency test selector. Again, the flow indicator should indicate flow and should remain visible for as long as the reset test switch is held. Each mask contains a microphone which is also tested during pre-flight. The microphone test is conducted as follows. On the audio control panel, set the mask boom switch to the mask position to select the oxygen mask microphone for transmission. Push the flight interphone and speaker switches so that audio is heard on the overhead speaker. Then hold the push to talk switch to the intercom position and push the emergency test and reset test switches on the mask assembly simultaneously. Oxygen should then be heard to flow over the intercom as picked up by the mask microphone. Once checks are complete, the mask should always be stowed with the normal 100% selector in the 100% position to ensure that pure oxygen is available immediately when quick donning is required. Supplemental oxygen is also available for the passengers. The oxygen masks for the passengers are located in the passenger service units above the passengers' heads. There are 4 masks and 1 chemical oxygen generator per passenger service unit. Pulling down on any one of the masks triggers a firing pin on the chemical oxygen generator that starts a constant flow of oxygen to all 4 of the masks. The oxygen generators generate oxygen through a chemical reaction by mixing sodium chlorate and iron. Once started, the flow cannot be stopped and is constant to all 4 masks regardless of whether they are being used. Each chemical oxygen generator supplies oxygen to its masks for about 12 minutes. There are also chemical oxygen generators and masks at the flight attendant stations and in the lavatories. In these cases, there is 1 generator feeding 2 masks at each station. Portable oxygen cylinders are also installed in the cabin for both emergency and therapeutic use. Just like the crew oxygen system, controls and indications for the passenger oxygen system are located on the aft overhead panel. The flight deck control for the passenger oxygen system is the passenger oxygen switch. Other than a hard landing, there are 2 primary ways in which the passenger oxygen system can be activated. With the passenger oxygen switch set to normal, the system will activate and the masks will drop from their compartments at a cabin altitude of 14,000 feet. The oxygen masks can also be deployed manually by setting the passenger oxygen switch to the on position. The passenger oxygen on light will illuminate when the passenger oxygen system has been activated. This light indicates that electrical power has gone to the oxygen deployment relays to open the passenger service unit doors and release the masks. It does not confirm that the masks have actually dropped, however. Illumination of the passenger oxygen on light will trigger a master caution, and the overhead light on the first officer's system annunciator panel will illuminate. The emergency lighting system consists of lights mounted inside the aircraft and lights mounted externally. Controls and indications for the emergency lighting systems are located on the forward overhead panel. The emergency lighting system is powered independently of the main electrical system. The internal and external emergency lights are powered by battery packs located in the forward and aft entry areas and on the cabin sidewalls. The battery packs are recharged by the main electrical system and take approximately 90 minutes to fully recharge. They hold enough charge to power the emergency lights for approximately 10 minutes. The emergency lighting system is activated automatically when DC bus 1 power is lost. Interior emergency lighting is installed to aid egress in an emergency. The interior emergency lights include exit signs, aisle lights, and floor proximity lights. Exit signs are located in the aisle ceiling and at each exit to show the location of the exits. Aisle lights are mounted throughout the aisle below the stowage bins to supply lighting to the aisle area. Floor proximity lights are laid down the left side of the aisle at floor level to guide passengers and crew to the exits. Photoluminescent strips either side of the aisle are a customer option to aid egress. These are mounted in place of the electrical floor proximity lights and absorb photons from ambient light, then re-radiate them over a prolonged period. This re-radiation of photons is visible to the eye in darkened conditions, most useful during an evacuation. Because the photoluminescent strips are charged by ambient light, they do not require power from the electrical system. They must still be recharged by electrical cabin lights during turnaround, however, and detailed charging information is provided in the FCOM. On the flight deck, there is a single emergency light co-located with the dome light to the left of the flight deck door that provides emergency lighting to the cockpit. This is also a part of the emergency lighting system, so will only illuminate when the emergency lighting system is activated. With the emergency exit light switch in the armed position, the emergency light switch will illuminate automatically if power to the DC bus number 1 is lost. Loss of the 2 AC transfer buses will also cause the lights to illuminate, as DC bus number 1 takes power from the transformer rectifier units, which in turn are powered by the 2 AC transfer buses. Exterior emergency lighting is also installed to aid egress from the aircraft in an emergency. Lights are installed in the fuselage to illuminate the escape slides, overwing exits, and the area aft of the wing to aid visibility in the event of an evacuation. The lights themselves are located aft of each exit: forward, overwing, and aft. There is a 3-position switch on the forward overhead panel that controls the emergency lighting. With the switch in the off position, the system is inhibited and the not armed light will be illuminated. Automatic activation of the lights is inhibited with the switch in this position. When capped, the switch is forced to the armed position. In this position, all emergency lights will activate automatically when power to DC bus number 1 fails and if normal AC power is lost, as discussed before. The on position switches on all emergency exit lights. The emergency exit lights may also be switched on using the emergency exit lighting switch on the aft flight attendant panel in the cabin. This overrides the flight deck control and will illuminate the emergency lights regardless of the flight deck switch position. The interior emergency lights are designed to help passengers locate the exits that they will use to evacuate the aircraft. The exterior emergency lights are designed to assist passengers once they have left the aircraft. A passenger evacuating from the Dash 800 variant has the choice of up to 8 emergency exits. The entry and service doors are equipped with escape slides, and these slides have inbuilt lights that illuminate the landing area. The overwing exits are not equipped with escape slides. The inboard sections of the wing are close enough to the ground that evacuation over the trailing edge should be safe so long as care is taken. Markings on the wings direct passengers rearwards towards the trailing edge. One item on the evacuation checklist is to select flaps 40, which should assist passengers in sliding down. Egress from the flight deck is possible by using the flight deck number 2 windows. To open the side windows, depress the trigger and rotate the handle inboard towards you. The window will move inboard and then slide back until it locks into the open position. There are escape straps located above both pilots' heads. It is a considerable fall from the flight deck windows to the ground, so the straps are used to hold onto to control the descent. There was actually fairly little in this lesson that has real utility for you while flying the PMDG aircraft, and it was perhaps a little irrelevant in places as a result. But regardless of that, we hope it gave you an interesting insight into a few of the systems more noticeable to you as a passenger. Clearly there is much more equipment on the aircraft that could be classified as emergency equipment, but we've run over some of the more prominent systems and features available that help mitigate risk during emergencies. In this lesson, we covered the flight crew oxygen system, passenger oxygen system, the emergency lighting system, and we talked briefly about egress routes from the aircraft in an evacuation. So again, in a real aircraft, consider your situation, listen to the cabin crew, and respect that safety briefing. But you knew that.